As we all know, density is equals to mass divided by volume. Our objective is to determine the densities of a regular and irregular object. To find the density of a marble, which is a regular object. Materials needed: electronic balance, measuring cylinder, beaker, 15 marbles, and a displacement can.
To find the volume of 15 marbles.
Firstly, we fill the displacement can with water. Make sure the water level is just beneath the opening of the metal tube. And place a measuring cylinder below the tube.
So here we have 15 marbles. And we are going to put them in the displacement can.
Sure that the water flows in the measuring cylinder. A question to wonder about: why did we use 15 marbles instead of 1? All the marbles are in displacement can. As you can see, the excess amount of water in the displacement can flows in the measuring cylinder. Find the volume. Make sure that your eyes are on the level with the water to avoid any parallax and error. 10 ml. To find the mass of 15 marbles. First, find the mass of the beaker. The mass of the beaker is 129.8 grams. Find the mass of the beaker plus 15 marbles. Drop all the 15 marbles into the beaker. Wait for it to stabilize. Mass of 15 marbles plus beaker is 210.8 grams. Now we find the density. Volume of 15 marbles equals to 10 ml, which is equals to 10 cubic centimeters. The mass of the beaker is 129.9 grams. The mass of the beaker plus 15 marbles is 210.8 grams. Hence, the mass of 15 marbles is 80.9 grams. The density of 15 marbles is 80.9 divided by 10, which is 8.09 grams per milliliter. The density of 1 marble is 8.09 grams per milliliter divided by 15, which is 0.539 grams per milliliters, rounded off to 3 significant figures. Hence, the density of a marble is 0.539 grams per cm cube. Have you figured out why we use 15 marbles instead of 1? So it's simply because we cannot find the volume of a marble itself. Have you got it right? Find the density of a cork, which is an irregular object. Materials needed: electronic balance, displacement can, measuring cylinder, cork, and a metal bob. Find the mass of the cork. Place the cork on the electronic balance. The mass of the cork is 1.2 grams. To find the volume of the cork, firstly, we fill the displacement can with water. As usual, make sure that the water level is just below the metal tube opening.
Okay.
Place the measuring cylinder below the other end of the metal tube. Drop the bob into the water in the displacement can and let the excess amount of water flow into the measuring cylinder. Now we record down the volume of the water on eye level to avoid any parallax error. It's 5 milliliters. A question to wonder about. What is the bob for? The displacement can with water again. Make sure that the water level is just below the opening of the metal tube. Now we find the volume of the bob plus cork. Attach the bob to the cork using the hook on the bob. Drop the cork with the bob attached to it into the water in the displacement can. Let the excess water flow into the measuring cylinder. Now we find the volume of the water by putting our eyes on level with the water to avoid any parallax error. The volume is 15 milliliters. So what is the density? Volume of the bob is 5 milliliters. The volume of the bob plus cork is 15 milliliters. Hence, the volume of the cork is 10 milliliters. Mass of the cork, 1.2 grams. Density of the cork, 1.2 grams divided by 10 ml equals to 0.12 grams per cm cube. Hence, the density of a cork is 0.12 grams per cm cube. Have you figured out why we need to use a bob? Because we needed a cork to sink so that we can take down its full volume, and we figured that a bob would do the job. Figure that out? That's the end of the video. We hope that you had fun watching this and also learned how to find densities. Till next time.